Welcome to another session. So in today's session, we're going to be looking at the inverse functions. So when we talk of the inverse function, we talk of the reflection of a graph about the line y is equals to x. So when we have our Cartesian plane like this, these are our x-axis and then these are our y-axis. So when you talk of our line y is equals to x, we talk of a line which cuts this Cartesian plane into equal parts. So this line here, it's y is equals to x. So we reflect any type of graph about this line here. So if we can look at a straight line, or before we can look at a straight line, let's talk about the notation of the inverse. We're having a function f of x, which is the original function. So to move from this to the inverse function, we have to denote it in this way: f to the power -1 of x. So this is the notation for the inverse function. So we denote the inverse function with to the power -1 there. Then, because we are reflecting this about the x, about the line y is equals to x, so what happens is that we are going to swap every x and y coordinate with each other. For an example, if we're having a point 1:5, which is the coordinate for this function, the original function, to obtain the coordinates for the inverse, we're going to swap the x and the y coordinates. So it means it's going to be 5:1. So these now are the coordinates of the inverse function. So this is how you can get the coordinates. So now let's suppose let's start with the straight line graph. Let's say we're having 3x minus 1. So this is the equation for the straight line graph. Then we know that we can find the x-intercept by letting our y value become 0. Then 0 will be equals to 3x minus 1, and then we take 1 to the other side. We're going to have 3x, which is equals to 1. And then we divide both sides by 3. We're going to have 1 over 3. In coordinate form, we're going to have 1 over 3 is to 0. And then for the y-intercept, we're going to, okay, this is the y-intercept. We let our x value be equals to 0. Then our y now becomes 3 into 0 minus 1. Then this is -1. In coordinate form, it's going to be 0 is to minus 1. So we have the points that we can sketch the graph of this straight line graph. All right, so we can sketch this, and then we can also determine the coordinates for the inverse function. It means for the inverse function, the coordinates for the inverse function is going to be 0 is to 1 over 3. And then this one will be -1 is to 0. So these are the coordinates for our function, the original function, and then this one is for the inverse. So this is for the inverse, this is for the original function. We are going to prove that. So if we were to determine the equation for our inverse function, we have our graph, which is y is equals to 3x minus 1. So to determine the equation of the inverse function, we're going to swap our x and y values. Where we see y, we're going to say put x, which is equals to, where we see x, we're going to put y. We interchange them. So this is 3y minus 1. Then what you need to do is to make y the subject of the formula. Then we're going to take the 1 to the other side. We're going to have x plus 1, which is equals to 3y. Then we divide both sides by 3. Then this one will divide this one. Then we remain with y, which is equals to x plus 1 divided by 3. So 3 is our common denominator here. So it means it's the same as x over 3 plus 1 over 3. So this one can be written as 1 over 3x. Okay, so now it means the equation for our inverse function is y is equals to 1 over 3x plus a third. So this equation, it's our equation for the inverse function, or you can denote it as y to the power negative 1 is equals to 1 over 3x plus 1 over 3, to show that this is the inverse function of our straight line graph. Remember, in the beginning we exchanged the coordinates. So we said these are the coordinates for the inverse. Now we have the equation for the inverse. Can we find the exact coordinates? Does math work? Let's check that. So for the x-intercept, we let our y value become 0. Then this is 0 is equals to 1 over 3x plus 1 over 3. Then we can multiply everything by 3 to remove the fraction. So this is 0 is equals to x plus 1. Then we take 1 to the other side. Then our x value now becomes negative 1. So this is negative 1 is to 0. And then for the other intercept, we let our x to be equals to 0. Then our y now becomes 1 over 3 into 0 plus a third. And then we're going to have 1 over 3. Then it means this is 1. Oh, this is 0 is to 1 over 3. So remember these coordinates. Negative 1 is to 0. Negative 1 is to 0. We have it here. And then the other one now, it's here. 0 is to 1 over 3. It's this one. So you see how the x-intercept became the y-intercept. So if we were to sketch the two graphs on the same set of axes, we're going to have something like this. So these are our x and the y-intercept, or y-axis. So the original point was 1 over 3 is to 0 and negative 1. So these are our points for the original function. Let me try to draw that. Something like this. So this is our graph y is equals to 3x minus 1. So this point here was 0 is to minus 1, and then this was 1 over 3 is to 0. And then now for the inverse function, our coordinates are in this way. So we have our x as negative 1, which is a point on the negative axis, a point here, and then we have this point 0 is to 1 over 3, which is a point here. So when we try to sketch that one, we're going to have a graph like this. So this is the inverse graph, which says y negative 1 is equals to our inverse, what was it saying? 1 over 3x plus 1 over 3. So you can see that we reflected our graph about the line y is equals to x. Remember, our line y is equals to x passes here. So this is our line y is equals to x. So this is the reflection, the mirror image of this graph. You can see how it was reflected about this line. The x-intercept became the y-intercept, the y-intercept became the x-intercept. So this is basically the reflection of our graph. When we talk of the inverse, we talk of the reflection of our graph about this line y is equals to x. So I hope it makes sense, so that we can move to the inverse of a parabola, or before we move to that, we can test whether the inverse is a function or not, because we already know that a straight line graph it's a function. So if we test that, let me do a vertical line test quickly. So it touches the graph, our original graph once. It also touches the inverse once. So it means this one is a function, also this one is it's a function. So it means the inverse of a function of a straight line graph is also a function. Then we can move to the parabola. Suppose we are having h of x, which is equals to x squared. From grade 10, you are given this type of equation. They want you to determine or to sketch the graph. We know that we can use the table method to say here we have our function, which is x squared. Then what is our y value? So we can start from the negative side going to the positive side. So we can start at -2, -1, 0, 1 and 2. So when x is -2, what is our y value? Then our y value will be 4. So when x is -1, then our y value is 1. Then when x is 0, our y value is 0. Then 1 correspond with 1. Then 2, 4. So these are our set of coordinates. Or one can say, no man, this is simple. We can use the method that we are used to. We can find the x-intercept and the y-intercept by letting x here to be equals to 0 and by letting y here become to 0. So this is 0 is equals to x squared. We take the square root both sides, then our x value now is 0. And then now here we can have something like this. Y is equals to 0 squared, and then now it is 0. So it means the coordinates here, it's 0 is to 0, and then even here it's 0 is to 0. Then if you are having this, how are you going to sketch the graph? You can use the advantage that you know that our function h of x is equals to x squared. Then the a value here is positive. Then we're going to have a smiley parabola like that. All right. So if you use this, then it means the set of coordinates that you're going to have is that when x is -2, then your y value is 4. When this is -1, this is 1. When this is 0, this is 0. Then when this is 1, this is 1 again. Then when this is 2, this is 4. These are the coordinates for h of x. And we can plot them and then have a nice parabola there, a smiley one. Okay, so what if we were to determine the inverse and you don't want to use the inverse, you don't want to determine the equation for the inverse? You can simply switch these coordinates by saying, for the inverse of this graph, we know that this will change to 4 is to -2. Then this one will turn into 1 is to -1. Then this one will remain the same. Then this one will be 1 is to 1 again. And then now this one will be 4 is to 2. Then now you know the coordinates for the inverse and for the original function. So when we sketch that, so these are our x and these are our y. So we want to sketch the original function. We know that it turns on the origin, or the x-intercept and the y-intercept is at the origin. And then we're going to have a nice smiley graph like this. So this is the graph of h of x. This is the original graph. Okay, so in order for us to determine the inverse, we interchange the coordinates, and we already have the coordinates there. So let's suppose negative 1 is to 1. Okay, this is negative. This is 0.1, 2, 3, 4, something like that. And then negative 2 goes with 4. 1, 2, 3, 4. Then this can be negative 2. Okay, it's fine. Let's say this point here, negative 2 is to 4. Let's say this is the point, negative 2 is to 4. And then here, it will be 2 is to 4. And then we have a point here, which can be 1 is to 1. And then this one is negative 1 is to 1. Then when we interchange that, those points will be the inverse. All right, so the inverse function of this graph, when you plot those inverses points, then now this point becomes 4 is to 2. Then our x value now it's 4. Then our y value now it's 2. It can be a point here. And then this one, similarly, it will come down here. You see? So the turning point will be the same. So our graph will be something like this. So this will be our inverse function. So this is h, negative 1 there at the top, and then x. So did we really reflect the graph about the line y is equals to x? So our line y is equals to x is a point here. That is our point. That is our line y is equals to x here. So, though this purple line y is equals to x. Then if I do this, let me do this. Let me redraw our inverse graph. It will be something like this. Yes, something like this. So this is the inverse graph. So you can see that we really reflected the graph about the y is equals to x. We interchanged the coordinates, and then this is how we obtain our inverse of the parabola. Okay, so they might ask that, is the inverse of a parabola a function? So you're going to use the vertical line test again. So when we check for the parabola, we can see that the vertical line test touches the graph once. So this is a tick. It means the parabola is a function. So when we test it on the inverse, then we have a different story, because the vertical line test touches the graph more than once. So it means the inverse of a parabola is not a function. So how do we determine the equation of this inverse? So remember, the original function is given by y is equals to x squared. So in order for us to determine the inverse function, we interchange. So this becomes x, and then this becomes y squared. We take the square root both sides, then our y value now becomes plus or minus the square root of x. And then here, remember our a value here, it's positive. So it means we're going to take positive answer here. So our y value will be equals to the square root of x. Or you can say y negative 1 there, square root of x. So this is the equation for our inverse. This is the inverse function. I hope it makes sense. And yeah, that's how we do the inverse of this graph of this parabola. And we know that the inverse function of a parabola is not a function. Then we can also look at the exponential. The exponential. It's very important to know the inverse of this exponential. So let's suppose you are given g of x, which is equals to 2 exponent x minus 2. Then they want us to sketch the graph of G and its inverse on the same set of axes in order for us to see that indeed we reflected the graph about the line y is equals to x, because that is what the inverse is all about, reflecting the graph about the line y is equals to x. So we have to, the first thing that we can see here is that our asymptote y is equals to negative 2. I want us to, okay, y is equals to 2, and then the x-intercept, we let our y value become 0. So this is 0 is equals to 2 raised to exponent x minus 2. We take 2 to the other side. 2 is equals to 2 raised to exponent x. Same base, equate exponent, then 1 is equals to x, because the exponent here is 1. Then our coordinates will be 1 is to 0. And then we can determine the y-intercept by letting our x value become 0. Then y will be equals to 2 to the power 0 minus 2. And then this will be 1 minus 2, which is negative 1. In coordinate form, it's going to be 0 is to minus 1. So we have our everything. We have the asymptote, we have the x-intercept and the y-intercept. It means we can sketch our graph. So before we can sketch our graph, I want us to determine the equation of the inverse of this graph. Or we can do this. Let's sketch the graph. Let's not rush. Let's sketch the graph of g of x. So this is our Cartesian plane here. So this is our x, and then this is our y-intercept. So our asymptote is at y is equals to negative 2, which is somewhere around here. So this is, no, my line is not straight. So this is the line y is equals to negative 2. Y is equals to negative 2. And then our x-intercept, that is the point 1 is to 0. It can be a point here by estimation, because we are sketching, we are not drawing. And then 0 is to 1, it's here. So this is 1 is to 0. And then this is 0 is to minus 1. And then now our graph will be like this, will be increasing, and then this side it will approach the asymptote. So this is the graph of g of x. This is our graph of g of x, the normal exponential graph that we know. Then when you want to draw the inverse function, we need to interchange the x and y's. So from here, our asymptote, where there was y, we put x. Then our asymptote will be x is equals to minus 2. Then when we find the x-intercept, the coordinates will change to be 0 is to 1. And then our y-intercept, it will change to negative 1 is to 0. Then we have these 3 points. We can actually put them on the same set axis as this one. X is equals to minus 2. Our x-axis minus 2 can be a point here. So we're going to have a vertical asymptote. So this is the line x is equals to negative 2. And then the intercept here is 0 is to 1. At this point, we know that x is 0. Then our y value is 1. So we're going to have 0 is to 1 here. Let me write it. 0 is to 1. And then here we're going to have negative 1 is to 0, which is a point here. Negative 1 is to 0. Then how will our graph go? Our graph will go like this. So this is the inverse. This is the inverse graph. Is it true? Yes. Why? Because you can see that if we bring the line y is equals to x here, our y is equals to x, we can see that we reflected this graph. It's just that it's not drawn according to scale, but you can see that this point was here, and then when we reflected it, it moved to this point, and also this point, it moved to that point. So you can see that we really reflected that, and our asymptote was here, and then now when you mirror image it, it will come here. So this is the reflection of the graph about the y is equals to x. So this yellow graph, it's our g -1 there, x. This is our inverse function. So let's determine the equation for the inverse. So to determine that, y is equals to, or let me use the original, okay, this is equals to 2x minus 2, like that. So we know that this is y is equals to 2x minus 2. So in order for us to determine the inverse, we interchange the y and the x. So here we want to determine the inverse of this graph. So we need to swap, or we need to interchange this. So having x, which is equals to 2 raised to the exponent y minus 2. Then we take this 2 to the other side. We're going to have x plus 2 is equals to 2 raised to exponent y. Then can we solve for y here using the algebra that we know? The answer is yes, but we need to include something new, which is the logarithm. So our y value will be equals to the log of the base of the y, which is 2, then to the power x plus 2. So this is the inverse of the exponential graph. This is how we find the inverse. It means g prime, is it g? Yes, or h of prime, yeah, h prime of x, h -1 there, x will be equals to log 2, then we have x plus 2 there. So this is the inverse function. The inverse of an exponential is the logarithm graph. That is the new graph there, which is the logarithm graph, which is the inverse of the exponential graph. So this is how we can use the knowledge of the inverse function there. You just interchange and then you reflect everything about the line y is equals to x. So I hope it provides a clarity, or it gives you what exactly is an inverse function. Okay, so you can see that when we use the vertical line test on either the original graph or the inverse graph, it will touch the graph only once, which means the logarithm graph is also a function. The only function that is not a function is the inverse of a parabola. Okay, so guys, this is the inverse function. So if you haven't liked the video, you haven't subscribed, please subscribe, share the video with your friends, and please comment down there on the comment section. And then this is from me to you. See you in the next one. So this was our little summary on these inverse graphs. So I will see you in the next one.